Hello guys, welcome on Tesla Adventures. In this video, today we are going to discuss the problem on the charge moving in the magnetic field, as well as I have mixed a concept of the collision with this problem. So you can see that in this problem there is a charge q which is projected from the origin with a velocity v and the mass of the charge is m. This charge will obviously go in a circle because magnetic field is in the perpendicular plane of this screen, and this will go in a circle like that. This charge will strike this charge which is initially at rest at this position, and the collision will be elastic. Now elastic collision means that their velocity will be interchanged. So this particle will be at rest after collision at this position, and this minus q charge will start to move with velocity v in this direction. Due to the fact that this minus q charge is negatively charged, and therefore magnetic force acting on this charge will be in the upward direction, so it will go in a circular path like that. Okay, so the time we have to find out the coordinates of these two charges at this time t1 3t by 4 and this time t2 which is 7t by 4. So it is given in the question that r is equal to mv by qb and collision is elastic, so E is equal to 1 and time period is 2 pi m by qb. So what we can do, that we know that first time when this particle will reach this position will be t by 2, and in another t by 4 time, which would be total 3t by 4. Okay, t by 2 plus t by 4 is 3t by 4. So in this complete 3t by 4 time, the particle 1 which is plus q was at this position at this time, and this particle was at this position. So the position of q will be, the coordinates of the position of q will be 0, 2r, and the coordinates of the position of minus q will be minus r, 3r. You can see that this coordinate is, this is y coordinate and this is 3r and this is minus r. Now in further some time t, this particle will go in a circle and again come at this point, and this negative charge will strike again this positive charge, and their velocity will now again get interchanged, and this positive charge will start to move down the circle like that. So it would start to move like that, and this negative charge will be at rest at this position. So till this position, the further time, first time at this position was t by 2, and furthermore it taken t time to come at this position. So total time at this position is 3t by 2, and we have to find out the position at 7t by 4. So it's 3t by 2 plus t by 4 is 7t by 4. So at this position it would be 7t by 4, and when this particle positive charge will be at this position, this negative charge particle will be at this position. So at 7t by 4, at 7t by 4 the position of minus q will be at 0, 2r, and the position of plus q will be at, this is r and this is minus r, minus r, r, where r is given as mv by qb. So this was a important problem of two particles colliding in the presence of magnetic field, and again we are ignoring the electrostatic interaction between these two charges, and it should be ignored until and unless it is mentioned in the question that we have to consider the electrostatic interaction. So we would be ignoring that interaction till that time. Now we move on the next problem, and now I'll be uploading the separate videos of each concept illustration problem. Thank you. In this question, you can see that a particle is projected with this velocity v naught I cap and v naught j cap. So one component is v naught in the x-axis and other component is v naught in the y direction, and this particle has a velocity initially which is root 2 v naught, and electric field is present in negative x-axis and magnetic field is present towards positive x-axis. So it is given in the question that in this situation we have to find out the all possible values of E by B for which this particle will be observed with velocity, net velocity v naught j cap after some time. So we know that the motion of this particle will be helical like that. Okay, this would be the helical path of this particle, and if we see the case from x direction, from this direction, then we would be watching the y-axis like that in this direction, and we would be watching the z direction like that, because z-axis in this case is coming towards us and we are now watching this scenario from the x-axis. And we know that initially the magnetic force will be acting on the particle towards minus z. You can see that velocity is along y direction and magnetic field is along x direction. So the force initially will be acting towards minus z. So this particle, this is y, this is z, and this is minus z. So this particle will be initially was initially going with velocity v naught towards y direction. So it would rotate like that. This would be the circle, and obviously it would also be coming out towards the observer if you are watching from x-axis. So we can easily see that it would be moving in the y direction each time when it would be completing the circle. So for t is equal to n times of time period, where time period will be 2 pi m by qb. So for this time, n times of this time, the particle will be having this velocity, as well as we also know that this should be the only net velocity, therefore there should be no x component of this particle. So which means that we already know that as this particle will move in the x-axis, further x-axis, then the electric force acting on this particle would be in the minus x direction. Therefore there will be a time when the electric force acting on the particle will be 0. So that time can be calculated. In fact, the velocity of the particle in the x direction will be 0, not electric force. So that time when velocity in x direction will be 0 can be calculated by v is equal to u plus at in x direction. So v is 0. U was initially v naught and minus a. A is the retardation due to electric field, which is q e by m, and t is the time. So t will be m v naught by qe. So this is the time at which this particle will be turning its position, and its velocity in the x direction will be 0, and the net velocity of this particle will be v naught. But we also know that this time and this time should be equal, because we know that each time when the particle will be at its initial position, then its velocity in the y direction will be v naught j cap. So we know that, let us use another page. We know that m v naught by qe, m v naught by qe should be equal to n times of 2 pi m by qb. So cancelling this q with q, m with m, we have to find out e by b. So e by b will be equal to V naught by 2 pi n. Okay, yeah. So we know that n is a integer, so n is 1, 2, 3 up to so on. So these are the all possible values of E by V for which this particle will be having the net velocity in the y direction only. Thank you. In this problem, you can see that there are two identical charged particles that are projected simultaneously from the same point with velocities v and v like that. And the charge of each particle is q and mass is m. Now they are also projected with the same speed v. So there is a uniform magnetic field B inside the plane of the paper, and we have to find out the value of v1 dot v2 at any time t, where v1 and v2 are the instantaneous velocities of those particles, and r1 dot r2 at time pi m by qb, where r1 and r2 are the instantaneous position vectors of those particles. So first of all, let us draw their trajectory. So if we draw the path of these two charged particles, then it would be circular path, and the path of this is the path of first one, and the path of second one would be also the circular path of the same radius, like that. This is of same radius, okay, but it would be like that, you can see. So the only difference between the instantaneous velocities, see, you can see that the time of circle for both of them is same. T1 is equal to T2 is equal to 2 pi m by qb. The radius of path for both of them is same, which is mv by qb. So the only difference between them will be the initial angle between the projection velocities, which is 60 degree. So at any time t, this let's suppose, for example, that this particle, I am drawing it again in the other diagram. See, this is the case, and like that. Okay, so initial velocity of this one is v, and initial velocity of this one is v, like that. I'm showing it here, yeah, and this angle is 60 degree. So at any time t, the velocities will be separated by this angle 60 degree only, and therefore we also know that the speed of the particles is constant always, because kinetic energy is constant. So we can say that v1 dot v2 at any time t is in fact v into cos 60. So this would be v square by 2. Okay, and at this time you can see that at this time, which is pi m by qb, they both will be at their diametrically opposite end to the projection point. So this particle will be at this point, and this particle will be at this point. So this is 2r again, this is 2r again, and the angle between both of these is 60 degree. So again, if we find out the value of r1 dot r2, then it would be equal to r in fact 2r into cos 60 degree. So it would be 4r square by 2, so it would be 2r square. So this is the correct answer. Thank you.